Okay, nice. Well, thank you so much for the invitation. And indeed, I just finished my PhD. And before we get started, maybe I can just have a show of hands. Who is concerned about the climate crisis, or climate change, or climate breakdown? Yeah. Okay, everybody. Who has changed their individual behavior a little bit? Maybe reduced meat consumption, or flying, or so on? Your hands. Okay, still quite a lot. Who's engaged in like public protest over climate? Okay, a couple of hands, 5, 6. Who's engaged in civil disobedience? Maybe risking arrest? Okay, nobody. Good. Now, what I want today, want to give you today is a really a broad overview of a couple of points, and we'll start with a kind of a bigger picture view on where we are today and where we are with the climate emergency, and then I want to reflect a little bit on why we have failed so far and why current policy is insufficient, and then the last bit I want to talk a little bit about climate action and what we can do as individuals and as groups. And to me, you know, climate change always felt like this distant, almost surreal threat. I learned about it in high school, maybe many of you did too, and it was about polar bears, and I was like, okay, I mean, sounds problematic, but surely the politicians will figure it out, and we can just continue. And so I muddled along, and I focused on, you know, individual lifestyle behavior change, going vegan, not flying much, and so on. But what rattled me out of my comfort, you know, was kind of the COVID pandemic, where I realized that things can change quite dramatically, quickly, and for the worse, and politicians and policymakers don't really have a handle on it. And so during the pandemic, I spent it on an island in pandemic isolation, and I became kind of incentivized to look again at the climate science. And I spent a year and a half really obsessed about it, you know, reading scientific articles, talking to climate scientists, going to conferences, doing courses, and organizing workshops and so on. And I realized over the weeks and months I spent doing that the situation is really much worse than I thought, like much worse than I thought. And in the summer of 2021, when I came back to Amsterdam from the island, I kind of started to engage in grassroots climate action movements, and in particular with Scientist Rebellion, and kind of helped set up and grow Scientist Rebellion Netherlands from like a core group of organizers into really a thriving academic community that's eager to create change. And I'm going to talk about this at the end a little bit. But so let's zoom out for the bigger picture. And Mother Earth, you know, is an old lady. She was born 4.5 billion years ago and has experienced a number of revolutions that made her what she is today. Yeah? 3.8 billion years ago, the first single-cellular life forms emerging, the origin of life. 2.7 years ago, the development of oxygenic photosynthesis, yeah? Creating an energy-rich, oxygen-rich atmosphere that then subsequently led to an explosion of complex life forms, culminating in the Cambrian explosion 550 million years ago. And life back then was quite rough, and we had 5 great mass extinctions, wiping off at least 75% of all species of the Earth. And 4 of them, ominously, were associated with climatic changes, global heating. The 5th one famously caused by an asteroid killing the non-avian dinosaurs. And if we look at kind of this reconstruction of temperature here, we see about 60 million years ago, viewing a kind of a hothouse Earth state at the Paleocene, Eocene thermal maximum, like almost 15 degrees hotter than pre-industrial, which is the dotted line here. And then we move kind of into a cooling period. This is not working particularly well, but you see we're kind of reducing the temperature. And about here, at 3 million years ago, we're in the mid-Pliocene warm period, where we have about 3 degrees over pre-industrial levels. You know, sea levels were 17 meters higher, crocodiles in the Arctic and so on. And about 1 million years ago, the Earth is shifting into a mode of oscillation where we have glacial periods and interglacial periods with a frequency about 41,000 years. So you see here, starting in from 1 million, we have glacial periods where it's cooler, right? Glaciers come on, and then we have a warmer period in the interglacial period. This is not working well, but you see these oscillations here in the third line, right? Cooler, warmer, cooler, warmer. Now, Homo sapiens emerges 300,000 years ago, roughly, navigating these periods, you know, these interglacial glacial periods, always on the run, on the move, you know. What happens 50,000 years ago, we move out of Africa, colonize the planet, and then in the last, coming out of the last glacial period, we see here 12,000 years ago, we move into the Holocene, okay? and the Holocene is wonderful. Yeah? The Holocene is where things really kick off. We develop agriculture independently across the world. We build civilizations that rise and fall. And at some point, we burn fossil fuels on an extraordinary scale. Okay? Starting with the Industrial Revolution, 18th, 19th century. And that increases the temperatures and now at about 1.1 degrees. But this is only one aspect of the massive changes that we're seeing and what Earth system scientists call, Earth system scientists call the Great Acceleration, okay, which started in 1950, where we became a planetary scale geological force. We see the population rising here from the 1950s, the urban population as well, and stark increase in the primary energy use, in the consumption of fertilizers, right? We figure out how to get nitrogen from the atmosphere, Haber-Bosch process, to artificial fertilizers, to grow crops much more effectively, efficiently, feeding the growing population. With increased dams, increased water use, increases paper production, tourism, all that kind of stuff. You know, the 1950s kickstart the Great Acceleration, and we're moving from the Holocene, okay, this wonderful period, into the Anthropocene, okay, into this new era that is dominated by mankind. And Will Steffen did seminal work on this, an Earth system scientist. He actually died 2 weeks ago, but he put this Great Acceleration on the map and made this term of the Anthropocene popular. So these are the socioeconomic trends, and these has consequences for the Earth system trends. And here on the next slide, we see the consequences. We see a stark rise in carbon dioxide, right, the most important greenhouse gas. Similarly, nitrous oxide, methane, the other two potent greenhouse gases. We see an increase in tropical forest loss, deforestation, domesticated land, sea surface temperature rising, and there's a little plateau around the 1950s, which I will explain later. Ocean acidification, and about 25% of the carbon dioxide we put out gets into the ocean, acidifies it, to the detriment of marine life. Nitrogen from the fertilizer goes to coastal areas, causes algal blooms, kills the marine life. Yeah? Terrestrial biosphere degradation, biodiversity loss, ecosystem degradation, and so on. Yeah? So it really becomes problematic from the beginning of the 1950s. The ozone, you see, we lose quite a bit, but then we fix it, right? We stabilize it with the Montreal Protocol in the 80s. Now, Earth system scientists make sense of this kind of assault on the natural world with the planetary boundaries framework. Have you heard of that? Couple. The planetary boundaries framework is a notion to quantify kind of Holocene-like conditions on various axes and whether we're overshooting those or not. So they give us a sense of whether we're in a safe operating zone with humanity, okay? And we're overshooting a couple of those boundaries. We see here on the top climate change, right? We're beyond the safe zone, which is 350 parts per million. We're about 420 parts per million of CO2 in the atmosphere. Ocean acidification, not quite yet. We have animal agriculture mostly being the culprit for the other overshooting planetary boundaries. Land system change, overshooting, we lost a third of global forests. We have an increase in biogeochemical flows of nitrogen and phosphorus due to our excessive use of fertilizers. We have biosphere integrity. We have a massive amount of biodiversity loss. Right? Maybe you've heard of this. This is the second great crisis next to climate change due to animal agriculture and agriculture more generally. Currently, we're about 100 to 1,000 in terms of the above the background extinction rate. Okay, so in terms of rates, extinction rates, we're in the sixth mass extinction, human caused. Okay, in terms of levels, we're not quite there yet. The other past extinctions were about 75% at least. There's no formal criteria, but currently we're in the single digits. But in terms of the rates, we're in the sixth mass extinction. And then recently, novel entities was quantified in terms of plastic pollution, you know, new viruses and so on. And you've heard probably that microplastics is like everywhere, right? So for some things, we cannot quantify it yet, but that doesn't mean we're fine. A year ago, we couldn't quantify this guy, and let's look where the heck we are, you know? Similarly, with the freshwater boundary recently proposed, actually we're also overshooting the green water boundary in terms of the soil moisture. So this gives us a sense of where we are in terms of the Earth system and whether we're overshooting the safe space. But we also want to provide decent lives for humanity, right? So we want to fulfill a certain social foundations, which includes, you know, good food, good water, enough energy, health, education, income and work, gender equality, social equity, and so on. And Kate Raworth has proposed this very nice framework of donut economics, maybe you've heard it, where truly sustainable development lives in this donut of not overshooting these planetary boundaries, but also not falling short on the social foundations. Okay? And researchers in ecological economics have used this framework and then applied it to countries. Right? They downscaled these biophysical boundaries and the social foundations and looked at, well, how do countries in the world do? And this is from 2021, Fanning et al. In Nature Sustainability. And they looked on the x-axis, you see the number of biophysical boundaries being transgressed. Okay? And on the y-axis, you see the number of social thresholds achieved. Okay? And this is data from 1990 to 2015, and you see kind of a time evolution. And what you see in the top right is the rich countries, right? It's Netherlands, Austria, Germany, and so on. And they are breaking multiple biophysical boundaries. Yeah? But they're achieving, on a global scale at least, also these social foundations. On the other hand, developing countries are not yet overshooting most of the planetary boundaries, but they're also not achieving the social foundations. And all of them, what you see here, the trajectory, is to first break biophysical boundaries and then achieve the social foundations. Yeah? So fundamentally, we have no country that is sustainably developed, and the pathway is always unsustainable. Okay? All countries in the world. What we need to be is we need to be in the left.
Sorry, sir. The microphone's off.
Okay, well then, thank you so much.
I'm sorry.
No worries. Okay, no country sustainably developed, fundamentally, okay? Big picture. Let's look at the climate emergency in particular. Right? This is one aspect of the planetary boundaries we're breaking, but it's certainly the most prominent one and possibly the most pressing one. Now, all important greenhouse gases are at record highs. Yeah? CO2, primarily from the burning of fossil fuels, rising methane from animal agriculture, cows burping, rice paddies, production of coal, leaking of gas pipelines, and nitrous oxide, also from fertilizer, excess fertilizer used in agriculture. All are at record highs. Yeah? If we look at the kind of a pie chart, if you want, of the problem, the greenhouse gases, mostly it's CO2 is the culprit, the main culprit, yeah, from burning of fossil fuels. Our energy system is extremely fossil intensive. Yeah? Over 80% of our energy is derived from fossil fuels. Yeah? There's also CO2 from deforestation, right? There's CO2 in industrial processes, in the creation of cement, for example. It's just a byproduct of the chemical process. It's hard to remove. There's methane from agriculture, right, from industry again, and there's also nitrous oxide from agriculture. Now the main thing is CO2 though, and there's a very nice relationship that emerges out of the complexity of the climate system, okay, which is a near linear relationship. Yeah? We love linear relationships, right? A near linear relationship between the historical cumulative CO2 emissions, which you see on the x-axis, okay? So we've emitted about 2,500 gigatons, billions of tons of CO2 since industrial revolution, and the extent of global average temperatures increase, right? So here it's a near linear relationship. So if you take the average of the last decade, so from 2011 to 2020, and you compare that temperature to pre-industrial, which is 1850 to 1900, we are about 1.1 degree over, okay? And if you take just the average of last year and the year before, we're about at 1.2 degrees, okay? Now the cool thing is what this allows you to do is to define a remaining carbon budget, okay? How much CO2 can you still emit until you reach a particular temperature threshold, yeah? And that allows you to draw these kinds of curves that are actually quite scary. So here what we're seeing is the historical emissions, yeah, on the y-axis, in black, rising, they're still rising, okay, globally. And we see mitigation pathways that are compatible with limiting warming to 1.5 degrees, okay. Now, if we had started in 2000, okay, I mean, it wouldn't have been a walk in the park, but it would have been much easier to mitigate global heating, because you see, it's not a particularly difficult pathway. Now, the longer you wait, because it's an integral, because the area under the curve is important, the longer you wait, the more brutal the mitigation pathway has to become, okay? So now, we need like mitigation rates about 7, 8, 10% per year, like a COVID dip every year to be on track to limit warming to 1.5 degrees, okay? what is particularly interesting is actually the more we learn about the climate system, the more concerned we become. So this carbon budget is the latest from the IPCC. Now there was an update just last November by scientists who found that actually we understand the system a little bit better and the carbon budget is much reduced. So from 2023, we thought we would have 9.5 years, okay, if we take 40 gigatons per year on average, okay, so 380 divided by 40, about 9.5 years, okay. And there was an update just in November, well, actually we understand it a little bit better, bam, shaved off 3 years, okay, 6.5 years, yeah. So the more we learn, the more concerned we become, and existing and planned fossil infrastructure is actually 3 times the remaining carbon budget, yeah. And I'll talk about this a little bit later when we realize what is physically necessary and what is kind of the current political system planning. And they are in stark contrast. In general, and this is kind of the IPCC, this is this important body that is summarizing the climate science. They had their 6th assessment report in 2021 and 2022. So there has been 6 reports, the first one in 1990. And they have different working groups. They have working group 1 on the physical science. They have working group 2 on impacts, adaptation, and vulnerability. And they have working group 3 on mitigation, okay? And each of these reports are 3,000 to 4,000 pages wide, long. And this working group 2 report came out last February, so 2022, and the headline is basically, climate impacts are worse than we thought and they're accelerating, okay? And you can see it, I mean, you can see it just if you look what's happening in the world, right? There was this extraordinary heat wave last year in Antarctica where we were just 7 sigma above the median, unheard of. You had heat waves in 2021 in the summer, maybe you recall them in the North Pacific, that slashed temperature records by up to 9 degrees, And you have famous climate scientists like Michael Mann saying, well, there's something else going on with this heat wave that we've seen in recent years that the models aren't quite capturing. And similarly, Rockström, look, these recent weather anomalies are not well represented in these computer models, right? And you had last year, India, Pakistan sweltering in extreme heat, over 1 billion people. You had Pakistan being underwater, 34 million people displaced. Just when we had the New Year's break, right, there was temperatures of up to 20 degrees in Germany, in December, in January. So the climate system is much more responsive, actually, to our perturbation than initially believed. And one area that makes this quite clear in terms of the research is this research on tipping elements or tipping points. And tipping elements are large-scale systems in the climate system that can respond non-linearly to increases in temperature. So take Greenland, for example. Now, Greenland, there's something called the melt elevation surface feedback in Greenland. So you have heating, okay? The ice melts, and the ice goes to the zone, goes closer, it changes in altitude, right? Reduces in altitude. Now it's warmer, lower than higher, which means there's a positive reinforcing feedback. But at some point it just continues to melt even when you don't increase temperatures, And possibly we've already gone past Greenland, and even if we stop now, Greenland just melts away. And once it's fully melted, it's very difficult to get it back. Like this notion of hysteresis, maybe you've learned this in this course already, right? The tipping point, and it's hard to push the system back into this good, stable state. And you have a host of tipping elements. You have the Amazon is hypothesized to be able to tip into a savanna. You have the AMOC, this Atlantic overturning circulation. Part of it is the Gulf Stream. It's hypothesized to have 2 stable states, on and off. And at the forefront of this research is this notion that they can be connected. Yeah? So, for example, you have a reduction in Arctic sea ice, which means you have less albedo, which means you have higher temperatures here in the north, increasing the ice loss in Greenland, which means more freshwater input to the AMOC, which means that is slowing down, which means there's less cool water here close to the Amazon, which means it's hotter there, and so on and so forth. So there are these connections. And if you just look at the evidence from tipping points, the risks that they provide is that we're in a state of planetary emergency. And you can see this here in a talk that Tim Lenton gave, who kind of coined this notion of tipping elements in a paper in 2008 with others, where you see in 2001 we were like, well, the risk of tipping points is at 4 or 5 degrees, we're in high risk, okay? And what you see here is that every assessment realized, well, it's actually much more urgent, okay? And now we're already in the danger zone at 1.5 degrees. In fact, there was a recent update in Science published last September saying exceeding 1.5 degrees could trigger multiple climate tipping points. Yeah? And we're currently at 1.2 degrees if we take the temperatures of last year. Well, we are headed for roughly 2.7 degrees by the end of the century. Okay? So this is 1.5 at the early 2030s, 2 degrees by 2050, and then at the end of the century, 3 degrees. Okay? Now, if you ask climate scientists, there was a survey done in 2021 asking IPCC authors, well, what do you think will happen at the end of the century? What's the extent of heating? And mostly, people don't think that 1.5 degrees is feasible at all, right? They say, like, look, less than 5% say 1.5 degrees. Many more say actually 4 degrees. Yeah? And the model answer is like 3 degrees. Okay. Now, 3 degrees. There was a famous book and blog post by David Wallace-Wells in 2017 looking at the worst case projections. What happens if we heat 5 degrees by the end of the century? And he said, well, the Earth will be uninhabitable. Yeah? And I think that's totally true. Now, we're not on track for 5 degrees anymore. We're on track for 3 degrees. But given the fact that the climate system is actually more sensitive to our perturbations, that climate impacts are worse than anticipated given an extent of heating, 3 degrees is probably the new 5 degrees. Yeah, and I've summarized some of the literature just looking at what happens when we at 2.7 degrees of warming at the end of the century. And it is probably, the collapse of organized human society. Yeah? And some very prominent scientists are actually of the same, see it similarly. The organized human society is possibly not, it's not possible under a 3-degree world. Yeah? And you have John Schellenhuber, the founding director of PIC, the Potsdam Institute for Climate Impact Research, probably the world's most renowned research institute for climate, saying, I think we have more than a 5% chance of succeeding, but it's definitely less than 50%. Yeah? But, what is the option? Yeah? If we have a final chance to save our culture and civilization, it's just compelled to do it. And there's a sentence, well, there's a cartoonish depiction that I think is quite interesting, also from Willsteffen 2018 paper, where we had in the past, we had this limit cycle, right? We had glacial, interglacial periods. In the Holocene, we love the Holocene. Well, we exited it, we're in the Anthropocene. And now we're in this decisive moment, okay? In this decisive moment in human history, where it's a question of whether we're able to steward the Earth back into a stabilized position, okay? Or whether we just continue to degrade the biosphere, emit more, and then, reach tipping points where things become self-reinforcing and it's basically game over here. And there's a sentence that stuck with me, and it's in the Summary for Policymakers of the IPCC report, Working Group 2. And it says, any further delay in concerted anticipatory global action on adaptation and mitigation will miss a brief and rapidly closing window of opportunity to secure a livable and sustainable future for all. Yeah? This is the scientific community telling us, look, guys, if you don't get our act together, we're fucked. And it's funny to be alive at this critical moment, no? And there's a scene in The Lord of the Rings, maybe some of you know it, that I think about a lot, yeah? And it's Frodo who says, I wish the ring had never come to me. I wish none of this had happened. And then Gandalf says, so do all who live to see such times, but that is not for them to decide. All we have to decide is what to do with the time that is given to us. And I think this is the moment we're in. It's really in the 2020s where we have to make the greatest progress on mitigation. We have to act hard and very strong now, not tomorrow. But it is instructive to think about why we have failed so far. Okay, like why we've known the problem for many, many decades, and still global emissions have risen and are still rising. Like, why is it such? Okay. And I'm going to drink a little bit of water, and then we will continue with this part. If there are clarification, if there's something's unclear, just feel free to ask and interrupt. But there will be a room afterwards for discussion also. So let's dig into it. Why have we failed so far? And I really like this review article, and I think it was under the reading, I'm not sure whether you got a chance to look at it, published in 2021 in October by a fantastic team of interdisciplinary scientists, physical scientists, social scientists, humanities scholars, and so on. And they looked at this question, why have we failed to bend the emissions curve? okay? And they looked at it through different lenses, and they came up with three clusters, okay? One is the Davos cluster, the rich and powerful, yeah? One is the enabler cluster, those that inadvertently, consciously or subconsciously enabled the status quo. And then the other one is the ostrich cluster, where it's just this notion of inequality and high carbon lock-in of rich countries that is not conducive to reduce the problem. And I don't want to talk about all of these lenses, I just want to pick some of them, okay? And I want to start with the vested interest of the fossil fuel industry. And here, it is very illustrative. It is very illustrative to look at how society's understanding of the problem has evolved over the years, and how big oil's understanding and actions have evolved over the years, okay? And the greenhouse gas effect has been well understood for centuries, actually. It was first proposed by Joseph Fourier of Fourier transformation fame in 1824. He predicted the greenhouse effect. It was experimentally established by Eugene Newton Foote in 1856. So she showed experimentally that air that is filled with more carbon dioxide warms up faster than without or with less carbon dioxide. We have 1896, Svante Arrhenius, a Swedish scientist, making the first quantitative predictions, asking what happens if we double the CO2 concentration in the atmosphere from pre-industrial levels, which is 270, to 540. And he said, well, we'll see a temperature increase of 4 degrees, okay? The best science today, the latest IPCC report, says the best estimate is 3 degrees with an uncertainty range of 2.5 to 4, okay? So Svante Arrhenius was in that ballpark over 130 years ago, okay? The question was not whether the greenhouse gas effect exists, but the question was whether our burning of fossil fuels can transform the atmosphere such that we will see global heating, okay? And so the first quantitative measurements of an increase in CO2 were in 1960 by Keeling, and he showed this famous Keeling curve, which you may know, the increase in carbon dioxide concentrations. 1965, we have the first official warning by government, the United States government, issuing this environmental report by President Lyndon Johnson saying, warning of climate change caused by fossil fuels, okay? We have in the 1970s this question of whether we're actually cooling or warming. Because if you see here the temperatures, this is some temperature data sets. You see here we have an increase, and then we're in this plateau area, right? And there was this debate of whether we're going to get a warming or we're going to get cooling. Yeah. And in the end of the 70s, that was kind of settled. And what's interesting, much of that masking here is due to air pollution. Was due to air pollution. Okay. So cities in London, New York, and rich countries had very bad air pollution. And once we cleaned up the cities, we had an increase in global heating. And that is actually quite a conundrum today, okay? Because fossil fuels kill 8.7 million people every year, just from air pollution, okay? However, they also mask, if you look at the IPCC, 0.5 degree of warming, yeah? So if we would clean up immediately all the air pollution, we would get hit with a lot of warming. Yeah? This is regionally heterogeneous. In China, India, South Asia, Africa, you have more air pollution. But it is quite substantial. Yeah? So again, the more we learn is, yeah?
How does the air pollution mask the heat?
It's just of the particles. Yeah. So what you have here is this conundrum, but in the 1970s that became clearer. Okay, we're actually on a warming trend. And in 1988, you have James Hansen, probably the most eminent climate scientist alive today, warning the United States Congress, saying, hey, global warming is detectable and we are the cause. Then the IPCC forms. We have the UNFCCC convening the United Nations Framework Convention on Climate Change in 1992 at the Earth Summit in Rio, where countries come together and say, yes, we want to prevent dangerous interference with the climate system. And we have kind of conference of the parties, these conferences every year from then on, right? We had one in Kyoto in 1997, famously. We had one in Paris, 2015, reaching the Paris Agreement, right? All countries saying we will limit warming to well below 2 degrees, ideally to 1.5 degrees, right? We have all these things happening there. At the same time, okay, we have fossil fuels understanding of the problem. And they were first warned in 1959 by the great physicist Edward Teller that your product is the problem. Okay? There's something called the greenhouse gas effect. Fossil fuels are probably the cause. Your product is our problem. In 1965, the president of the API, the American Petroleum Institute, warns big oil, saying, look, actually this report makes very clear that we're the problem and we have an issue here, because we're selling a problem. We have Exxon starting a research group, hiring scientists, looking into the climate problem. Are we really the problem? How bad is it? Okay, they wanted to become a player also in the scientific community. And they realized, yeah, we're the problem. And they made very precise quantitative predictions, okay, of if they continued as they did, what would happen. Yeah? Very precise quantitative predictions. There was a paper just recently in Science by Supran Ramsdorff and Naomi Oreskes looking at the quantitative predictions of Exxon and where we are today, and they are starkly similar. Okay? Well, that research project got axed at some point because the company realized, oh, we're selling fossil fuels. Okay, this is clearly a conflict of interest here, so let's axe the research. And we have in 1980 the first kind of public deception where the API, this lobby group, argues for a tripling of coal, because of energy security reasons and so on, even though they knew that this would cause increased global warming. We have a strategy meeting in the 80s where the oil majors came together and they mapped out a strategy. Well, how can we avoid regulation? Because they realized, well, we are a problem. Big government is probably going to regulate us out of existence because they're interested in a livable future. How do we counter that? Okay. And they said, well, we need to emphasize the uncertainties. Okay. We need to stress the cost of action. Yeah? We need to insist on detection before action. We need to focus on policies that do not threaten fossil fuels. And they then meticulously implemented the strategy. Yeah. And just engaged in enormous delay in public deception. And there's a great documentary, The Power of Big Oil, which I can recommend you watch, going through, from the 1980s, what they did in terms of the delay. And it's really astonishing. It is really astonishing. I think, when all is said and done, okay, these executives and these corporations will have caused probably the greatest crime not only in corporate history, but in all of history, okay? And they are free today, running around, still making an enormous amount of profits. Probably seen it recently. Shell, BP, Exxon profiting from the cost of living crisis, from the energy crisis, and so on. Enormous amount of profits. And, today still, they have no real plan to clean up their act. Yeah? They're greenwashing, they're labeling fossil gas as renewable. Okay? They're hitting the brake on the renewables because they realize fossil fuels are fucking profitable. Okay? And they are suddenly backing off their climate promises, okay? And fundamentally, this is because they're interested in profits, okay? And this is this fundamental glitch in our economic system. And you can see it, the Shell CEO saying, just 2 weeks ago, let me be categorical in this. We cannot justify going for a low return. Our shareholders deserve to see us going after strong returns. If we cannot achieve double-digit returns in a business, we need to question very hard whether we should continue in that business, Absolutely, we want to continue going for lower and lower and lower carbon, but it has to be profitable, okay? Fundamentally, the incentives of the corporation, okay, are misaligned with a livable future. Yeah? And there's a great documentary which I actually recommend to you. It's called The Corporation. I'm not sure, maybe some of you have seen it. It's a really fantastic piece of work in the early 2000s based on a book analyzing the corporation from a psychological standpoint and just concluding, okay, corporations are actually psychopaths. Yeah. And it is really important to understand that these oil majors are not interested in the energy transition. They are interested in making profits. And as long as fossil fuels are profitable, they will drill and they will undermine a livable future. And it's quite interesting to see people, also senior people, not getting this. So there was recently an opinion piece, by professors of this university arguing that we need Shell for the energy transition and so on and so forth, right? And it's like, guys, they are not interested in an energy transition. Yeah? We have to end them before they end us, basically. And there's a fake ad done by Adam McKay. I'm not sure whether you know him. He was the director of Don't Look Up and Vice and a couple of other great movies. And he made a fake ad for Chevron. I'm just going to watch it as a kind of a visual pause here. Yeah, usually, it should start, but yeah. I'm sure you can hear this one.
We at Chevron believe that nothing is more precious than life, and that the most precious life of all is the dead kind, that has been compressed for hundreds of millions of years under massive rocks until it magically becomes oil. Oil that we can refine and sell as gasoline. So a cool-ass tank can crush a clay hut, or an airplane can take a businessman 3,000 miles to have dinner with someone, or whatever. All the while releasing greenhouse gases that are transforming the planet right this second into a hellish George Miller film. Because at the end of the day, we at Chevron straight up don't give a single fuck about you, your weird children, or your stupid ratty-ass dog. And we have billions and billions of dollars to pay for this commercial time, this cheesy footage, and this bullshit music. All so that you will be lulled into a catatonic state that makes you forget one singular fact. Chevron is actively murdering you every day. See, the human brain can only deal with so many things at once, so these emotionally loaded scenes will always push aside other thoughts like, Chevron is murdering me. It's just how our brains work, you meat puppet who exists only to feed us profits. Chevron, it's hard to even comprehend how little of a fuck we give about you. And this commercial also applies equally to Exxon, BP, Shell, or delinquent lapdog media and any hack politician who's trading the future of life on this planet for filthy money and oil stocks.
Okay.
You want to have a break now?
Yeah, maybe we have a little break. I just want to conclude with basically, I think it's been clear that the fossil fuel industry has caused an enormous amount of delay and is certainly very important in trying to understand why we haven't bent the emissions curve so far. But let's take a break now and then we're back. Okay, let's continue. And there was some discussion in the break on, on hope and ending on a positive note and stuff like that. And maybe we will, but I think it's important that we just look the fact into the eyes, okay? And we really also emotionally connect to what's happening. I think that's very important. And then in the end, maybe we'll have I hope we'll have a positive, at least actionable thing that we can do. But let's continue here with why we've failed. And there was the vested interests, there was the protecting the status quo, protecting the powerful. And then I want to be a little bit more academic, talking about the enabler cluster and talking about mitigation modeling. And I'm going to sketch this a little bit. And there's lots of additional material for you linked in the slides, scientific articles, podcasts, lectures, books, documentaries, and so on. And I'll share that with you. But I just want to give you an overview. In terms of the mitigation modeling, of course, this is a working group 3. We're talking about working group 3 now, right? And we can't predict the future. Nobody can. But we can create scenarios and think about, well, what if we did this? What if we did that? How would society, how would the climate system evolve? And in the IPCC, they're using so-called shared socioeconomic pathways, kind of storylines of how things can unfold. And you have SSP1 about sustainability saying, yeah, we will get on track with the targets, we'll reduce economic inequality, reduce economic growth, population growth, and so on. And we're kind of on a good track. Or you have like middle of the road where you just mumble along like you've done in the past, continuation of these trends, and so on, or you have rapid growth, rapid economic growth fueled by fossil fuels. And these different scenarios are compatible with different global heating at the end of the century. So for example, this rapid growth scenario is compatible here with 6 watts per square meters by the end of the century. It's just a measure of net energy outflows, or basically global heating. So that would be like 5 degrees at the end of the century, right? And we are kind of along the trajectory of SSP2, 4.5, about 3 degrees by the end of the century, right? And so you have these scenarios, and those you can feed into what's called integrated assessment models. And these are enormously big, enormously complicated models. This is dying, no. That are kind of modeling, the economy, the climate system, the energy system, a land system change, and you can feed it assumptions about GDP. How does GDP evolve, right? The economy. How does the population evolve? And then you can ask like, well, what if we do a carbon tax, right? Or you can ask like, I want to limit warming to 2 degrees, optimize for me, And then you can see, well, what are the outcomes? What are the emissions? How does the energy system look like at the end, and so on, right? So these are kind of the big models that the IPCC uses. And they have been criticized quite a bit for a couple of assumptions they make. So they are firmly based in new classical economics. are kind of rational agents, markets that work. Any reduction in economic activity is by definition a cost, right? You have this notion that we can decouple economic growth from emissions, and I'm going to talk about this a little bit later. You have this notion of a discount rate where you weigh near-term costs more heavily than those in the future, right? Because in the future it's probably cheaper to solve the problem. So there's an inherent notion of action today being more costly than action tomorrow. They have underpredicted the fall of the cost of renewables quite dramatically, actually. So this is a good thing for the real world, but it's a bad thing because in terms of policy, they have overstated the cost of rapid decarbonization. So if we look here, for example, it's really absolutely tremendous, the fall of costs in renewables. So in solar energy, for example, in terms of electricity, declined by 90% in the last 10 years. Yeah? You have here on the left, you have the installed solar capacity on the red line, and then predictions by the IEA. I mean, it's like, it's incredible, no? And even 2022, latest report already outdated, yeah? And there's great modeling work by Rupert Way and Doyle Farmer at Oxford and so on, looking at just doing a fast renewable energy transition would save us trillions of dollars, just in terms of the cheapness of the energy source, even if we ignore climate change. Yeah? So there's a huge opportunity here. But the integrated assessment models generally have overstated the costs of this decarbonization. They're focused on like market-based solutions. If we just do a carbon price, you know, it's going to be fine, even though it's politically very hard to do a carbon price for obvious reasons. And they focused on technological innovations such as large-scale negative emissions technology, very much on the supply side, okay, not on demand side, not on behavior change. Yeah? Actually, only recently, the sixth assessment report had a chapter on demand-side solutions. Yeah? Earlier, it didn't even have a chapter. And I'm going to talk about the negative emissions technologies now because I don't think it's well understood, but it's actually something that shook me a little bit. So if we here look at, this is from a paper 2016 by Anderson and Peters, a very good paper on negative emissions technologies, okay? And here's just a scenario. It doesn't matter too much. You have gigatons of CO2. And what you find, this is just the emissions from fossil fuels and industry and land use change. And in most of the scenarios, at some point, you assume you can suck out gigatons of carbon from the atmosphere, okay? And what's important for the climate system is to reach net zero emissions, okay? So you need to balance what you put out with what you put in. And here at some point you reach like net zero, but you can have that while continuing to burn fossil fuels as long as you suck out the carbon, okay? And one technology that has been proposed to do this is bioenergy carbon capture and storage, okay? Which means growing crops on large plantations, and growing crops, you know, absorbs carbon from the atmosphere, burning that in specifically designed power plants, and then storing the carbon underground, okay? So in theory, you have negative emissions technologies, but it's incredible in terms of just the land use that will be required to do this, okay? So it's a very tunnel vision solution if you look at ecosystem degradation, biodiversity loss, just agriculture we need in terms of crops. If you look at the latest IPCC report, Working Group 3, you can look at the scenarios, which is what I've done here. And here's in 91 of the 95 scenarios, limiting warming to 1.5 degrees with limited or no overshoot. Okay, so you don't shoot over 1.5 and come back, but you've limited overshoot. You have about 334 gigatons in this century in removal. So this is about 4 gigatons per year. Okay, 4 gigatons per year. With high overshoot, you have more, and all scenarios of 2 degrees are about also 3.6 gigatons. Now, how much is that? How much is that? Let's think about it. I mean, we have about more than 40 gigatons we put out every year, so this is 10%. Well, how much do we suck out today? Turns out there was a big report coming out in January on the state of carbon dioxide removal, noticing that per year today we suck out about 2 gigatons, okay? But this is from reforestation, afforestation, ecosystem restoration. It's not from bioenergy carbon capture and storage, which is only like 0.1%. Okay, so this technology is nowhere near ready to be employed at scale. Same with direct air capture. It's currently much too expensive and probably not available at scale. So these models assume, in a sense, this technology to be available in the future. Okay, and it's really, as Anderson and Peters call it, it's a high-stakes gamble. Because what if it's not going to be available, okay? then you can't just suck out gigaton scale CO2. And there's some research showing that, look, even if you just assume a 10% chance of failure, okay, just proper risk management, you have to double the mitigation rates, okay, to ensure that you're not risking too much, okay? So large-scale negative emissions technologies delays action, perpetuates the status quo, okay? This is one aspect, how the mitigation community inadvertently, consciously or subconsciously, has enabled the status quo. The second point is about decoupling. Yeah? And there's this notion that we may be able to decouple economic growth from carbon emissions. Okay? And there are two types of decoupling. There's relative decoupling, where you don't grow as fast, but that's still a problem because you're still emitting. What you need is absolute decoupling. Okay? You need to reduce emissions while growing economically. This notion of green growth. And that's basically the dominant political hegemony. Okay, we're going for green growth. Now, it turns out, if you look at the literature, and people have done this, a famous review here, Helmut Haberl 2020. I apologize, this is a little academic, but I think it's interesting. He says, first of all, that the large majority of this literature, okay, does not question the GDP growth paradigm. Okay, even if the empirical evidence suggests that it's contradictory to officially committed climate policies. Okay, and policy recommendations here point towards a standard repertoire of efficiency, technology, innovation that is not further discussed or questioned. So there is a dominant, kind of stream in the mainstream analysis of climate change that is not questioning, well, is economic growth actually a good thing? Shouldn't we move beyond economic growth toward a post-growth future, maybe a degrowth future? Yeah. So it's again limiting the discussion. And Helmut Haberl note, look, large, rapid absolute reductions of resource use and greenhouse gas emissions cannot be achieved through observed decoupling rates. Okay? Decoupling needs to be complemented with sufficiency-oriented policies and strict enforcement of absolute reductions. So it's again questioning this assumption that is inherent in these models that we can just decouple emissions from economic growth. So it's again a little bit of a gamble. Well, maybe it doesn't work now at the rate required, but maybe it works in the future. And it's again perpetuating this dominant discourse of economic growth being just a good thing, something that's inherently valuable, and so on. There's another thing. So I mentioned integrated assessment models being these complicated models, but they're also simple integrated assessment models that have been used by economists to calculate the social cost of carbon. Okay, so how high should my carbon tax be, right? It's a difficult thing to quantify because it depends on how bad climate change will be and so on. And there are two key papers which I really highly recommend looking at these models. And there's 2013, Robert Pindyck in a paper, I just read the abstract. Climate change policy, what do the models tell us? And he says very little. A plethora of integrated assessment models have been constructed and used to estimate the social cost of carbon and evaluate alternative abatement policies. These models have crucial flaws that make them close to useless as tools for policy analysis. Certain inputs, the discount rate, right? How much should I discount the future? Are completely arbitrary, but have huge effects on the social cost of carbon estimates. Right? So Trump, for example, put it very high and said $7 is fine for a carbon tax. And Obama was like, no, we discount much less. And so we have a higher carbon tax. So it's completely arbitrary. The model's description of the impact of climate change are completely ad hoc, with no theoretical or empirical foundations. And the models can tell us nothing about the most important driver of the social cost of carbon, the possibility of catastrophic climate outcome. IM-based analysis of climate policy create a perception of knowledge and precision, but that perception is illusory, okay, and misleading. Now, William Nordhaus, who has spearheaded this analysis, has gotten the Nobel Prize in economics in 2018, okay? And in this lecture, which is really astonishing, it's an astonishing lecture, he says that 4 degrees is optimal. 4 degrees is what we should go for at the end of the century, okay? That's the most cost-effective solution to climate change. Now, as you remember from my previous part, 4 degrees is the end of the world, And climate scientists and some climate scientists I know are very angry at this kind of work. And Steve Keen has written really a fantastic paper in 2020 on this called The Appallingly Bad New Classical Economics of Climate Change. And I think that should interest you if you're interested in complexity science and so on, and how models can mislead us, poor models. And he says forecasts by economists of the economic damage from climate change have been notably sanguine. 4 degrees, compared to warnings by scientists about the damage to the biosphere. This is because economists made their own predictions of damages using 3 spurious methods. Assuming that about 90% of GDP will be unaffected by climate change because it happens indoors, okay? I was like, using the relationship between temperature and GDP today as a proxy for the impact of global warming over time, right? And using surveys that diluted extreme warnings from scientists with optimistic expectations from economists. Yeah? Nordhaus has misrepresented the scientific literature to justify a smooth function of, to describe the damage of GDP from climate change. Correcting for these errors makes it feasible that the economic damages from climate change are at least an order of magnitude worse and may be so great as to threaten the survival of human civilization. I mean, it's like, if somebody wrote a paper like this about my work, I would be like, damn, you know? So shots fired. But if you read it, it's really well argued and strong. And it's really, I mean, I couldn't sleep for a couple of days reading this because I thought, like, this can't be real. But then you watch the Nobel lecture, and then he just shows it on the slide. So this is one way in how inadvertently, you know, parts of the scientific community in economics have enabled the status quo by downplaying the risks of climate change, by saying it's going to be fine, you know, 4 degrees, you know. That has cost us dearly. It has really cost us dearly. Now, let me see how I'm doing in time. There is another part of the enabler cluster. 45 minutes. Yeah, 45 minutes, no? Half an hour.
You have half an hour.
Half an hour, okay. I thought 45 minutes. Oh, yeah, half an hour, okay. Well, I wanted to show you a video. Maybe I don't do this now, but I leave it in the slides. That talks a little bit, is one of my favorite interviews with Noam Chomsky and Andrew Marr on BBC. And he talks a little bit about, maybe some of you know it, he talks about whether journalists are self-censoring, you know, and whether they're kind of, you know, self-censoring. And Chomsky says, look, I don't believe you're self-censoring. You know, you're not self-censoring. It's just that if you believed something different, you wouldn't be sitting here, okay? And this is the idea that the way certain professions and certain norms evolve, they allow only a small range of what's possible, okay? So if you're in neoclassical economics, you're not going to write a radical critique on growth because it's just not within the purview, you know? If you're a senior scientist, you're not going to go onto the streets engaging in civil resistance because you realize, well, this is not in the social norm, okay? Very sensitive to social norms. And I highly recommend you watching this little video on your own, because this lens of thinking through why is that person saying what he is saying, qua his position, is very important. And you see it with the media, for example. I mean, the media has done a terrible job historically reporting on climate change. Right? I mean, the BBC, up until 2017, I think, had this policy of when you have a climate scientist on, you also want a climate denier, you know, climate skeptic, just to create balance. You know, I mean, if it's raining outside and you're a journalist and somebody says it's raining, you're not, you know, getting another opinion and saying, oh, it's not raining. You get out of the fucking window, you know, and look whether it's raining. And so it's really a problem on the media landscape, you know, again, owned by rich people who are protecting the status quo, Murdoch, Wall Street Journal, Fox News, right, very climate skeptic outlets, but also just the business of the media in terms of relying on advertisements. I was talking to some activists in Germany, and they said they were part of a meeting where a head of a newspaper said, look, we're not going to write something radically critical of Volkswagen, for example, because Volkswagen is buying ads, you know, it would just, we would lose them as a client. And so they're kind of self-censoring on a system level. Now let me talk a little bit about this ostrich cluster and about inequity in high carbon lifestyles, because that's also something that's only recently being put more and more into the purview of the analysis. There's a great work by Lucas Chancel. I mean, he's a French guy. I think it's Lucas Chancel or something. But he did excellent work looking at carbon inequality from 1990 to 2019. And you see here the emissions, share of total emissions in different groups, right? And you see that the top 1% of the world, okay, this is 17%, top 1% of the world emits 17% of the emissions, okay? So this is 80 million people now that we crossed 8 billion. And the bottom half, 4 billion, emit 11.5, okay? So the top 1% emit more than the bottom half of all of humanity, okay? So it's not a problem of population, it's a problem of consumption. And the top 10% emit 50% of the emissions, okay? The top 10%, 800 million people, 50% of the problem, okay? And what you see when you look at it historically, you can ask, well, which groups have grown in terms of the emissions? And you see, so here in the x-axis, the emitter group, the percentile you're in, right? And you see the emerging countries, like China, India, of course, increasing their emissions because they're developing. You see degrowth of low and middle class emissions in rich countries. But you see an enormous, this is the top 1%, you see an enormous growth in emission. So they are responsible for 23% of the emissions growth. And so you can ask yourself, well, what variable explains this? And it's affluence, right? It's wealthy, yeah? Because the wealthy can easily travel by airplane, private jet, car, much more transport emissions. And there's this continued argument now that we should shift the focus from the super poor actually to the super rich. And if you look at it here in terms of the climate targets, so this is again from Chancellor, looking at the US, the 2030 targets, okay? The bottom 50%, they don't need any reduction. They're fine. The top 10% need an enormous amount of reduction. Yeah? So it is a problem of class on some level. And there's this very nice book, Climate Change as Class War, recently, providing kind of this Marxist analysis of where actually the rich are destroying the planet, and the damage is irreversible, and we have to stop them. I should note, though, that in the top 10%, I am in the top 10%. Okay? So the top 10% in terms of income is about 34,000 euros. The top 1% is 120,000 euros. So if you make that, you're on average in that cluster. But then, of course, you have the super rich, right? The billionaires who are emitting an enormous amount more, right? So due to the yachts and the other big houses and private jets and so on and so forth, right? And in the system that we're here today, they, of course, have a lot of power, right? People, for some reason, listen to Bill Gates, what he has to say about climate policy, And he's not going to say, well, we need to socialize Shell and we need to move towards a post-growth economy and so on. He's not going to say that, right? He is protecting his high-carbon lifestyle, his status quo. And that's a part of the reason, again, why we have kind of failed to bend the emissions curve, because we haven't seen it in this view of a elite of rich people kind of dominating the discourse, and we haven't looked at this through this class lens, which I think is quite powerful, also in terms of mobilization, because it's not that the vast amount of us has to drastically change our lifestyle. It's mostly rich people. Now, in this analysis, there's a nice quote by Bill McKibben. He was one of the heroes of the environmental movement. He wrote the first book on climate change in the 80s. And he said, I've been there all along, and it's taken me too long to figure out what was happening. I wrote the first book about climate change, and I kept writing more books and articles and having symposia on the theory that if we kept piling up enough data and reason, eventually the powers that would get to work. Why wouldn't they, I thought we were in an argument, and it took me too long to figure out that we won the argument, but that didn't mean anything. We won the argument. The science was entirely robust and clear. We were just losing the fight, okay? Because the fight wasn't about data and reason. The fight was about money and power, which is what fights are always about. Yeah? And I think it's this realization that is not some kind of information deficit, or if only they would know about climate change and so on and so forth, but it is the powerful, the status quo, the corporations protecting their interests, okay? Now, let me, given that I only have 25 minutes left or so, let me give a short review based on what we've learned now, why current policy is insufficient, and then we talk a little bit about climate action, okay? What can we do now as individuals and in groups? Now, why current climate policy is insufficient? You have these net zero targets. Out of the physical science grew this notion that we need to get to net zero. So all these countries and corporations, they have these net zero targets. We want to reach net zero by 2050 globally, very important, and so on. And many emissions are covered by net zero targets. However, most of the net zero targets are inadequate in terms of there's not enough information. They only exist kind of in some documents rather than in law and policy. It's all really, many rely on carbon offsetting, which is kind of scandalous and doesn't work and so on. But even if we assume that net zero by 2050, even if we assume these kind of targets will be followed through, here's 6 reasons, okay, why it will be inadequate. Okay. The first reason is first, equity considerations imply a much faster decarbonization rates for rich countries. Right? Remember, net zero by 2050 is a global goal. If the Netherlands says we want to reach net zero by 2050, they are not taking into account that they have historically emitted an enormous amount and there's no carbon budget left for them. They're in overshoot. Okay? So when they talk about net zero by 2050, they are not taking equity into consideration. Right? Remember this kind of graph. They're overshooting. And 23 rich developed countries have caused half the problem, yeah, including the Netherlands. And there's a recent report by the Tyndall Center who just looked at the carbon budgets and said, well, what would actually how would an equitable phasing down of fossil fuels look like? And they said, look, for developed nations, coal production needs to fall by 50% within the next 5 years and completely phased out by 2030. Okay? I mean, it's not discussed at all in climate policy, right? For the wealthiest groups of producer nations, this includes the Netherlands and so on, output of oil and gas needs to be cut by 74% by 2030, completely phased out by 2034, okay? This is the physical reality if we take equity into consideration. It's not being discussed. Now, net zero by 2050 gives us only a 50% chance of limiting warming to 1.5 degrees, okay? Remember, these carbon budgets are very complicated. They're associated with probabilities, okay? And the carbon budget that is being discussed is a 50% chance. Now, there's recent research very nicely quantifying the uncertainties, Damon Matthews et al. 2021, saying actually, look, there's already a 17% chance that we have no carbon budget left, okay? And if we stop emitting anyway, we'd reach 1.5 degrees because of the masking and so on. So already now we're living on borrowed time. And as I said earlier, the carbon budget also got slashed by 3 years just because we learned more about the climate system. So banking on net zero by 2050 is really quite risky. It relies on negative emissions technologies that are unproven at scale. We looked at this, right? Here, the IPCC report. We rely on unprecedented rates of decoupling, okay, which is also a gamble. We looked at it as well. We realize that climate impacts are worse and they're accelerating, right? This is not incorporated in the latest climate policy, of course, because this is the latest science. But most importantly for us as individuals and also what we should do is that governments are saying one thing and doing another, okay? So you can have all these academic debates, it's actually carbon budget is much worse, blah, 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 blah. But if you're just a common sense person, you realize that they're saying one thing and doing another. So if governments are serious about the climate crisis, okay, then there can be no new expansion of fossil fuels. Okay, this is from Fatih Birol, the executive director of the International Energy Agency in 2021. Not a particularly progressive institution, by the way. Governments plan, however, actually to produce twice the amount of fossil fuels in 2030 that's consistent with limiting warming to 1.5 degrees. Okay, here you see it for coal, you see it for oil, you see it for gas. There's a whole list of countries, including the Netherlands, increasing the expansion of fossil fuels. Yeah? And these are, as the Secretary General of the UN notes, the real radicals. Okay? It's not people on the streets. It's governments expanding the fossil fuel industry. Yeah, it's crazy. And of course, the companies, as we noted earlier, they're making a killing. I mean, they're having historical profits, as high as never in history, and they still plan to spend many millions a day, okay, on expanding new oil and gas. Yeah. So we're in this situation, okay? Yeah, we're in this situation. Our house is on fire, but we're being told it's kind of fine, okay? We're discovered, renewables and so on, yeah? Electric vehicles, yeah? And I think this is the real scenario, if we continue as we do. And I think what we have to do is we have to shift into emergency mode, okay? We have to understand that this is the greatest crisis we've ever faced, and we have to really get going. And one historical analogy is, maybe not the best analogy, but it is at least in terms of the economic transformation, is the US entering the Second World War, okay? And it was incredible. Government spending rose tenfold, okay? Currently, the Dutch government spends more on fossil subsidies than on the energy transition, okay? 3 times more. Here, government spending rose tenfold. They had speed limits to conserve fuel. They banned the construction of new homes. They rationalized gasoline, They had posters saying when you ride alone, you ride with Hitler, You have waste helps the enemy, So you really had income taxes of up to 94%. You have an economy shifting into emergency mode, to avert that threat. And I think that's also what we have to do today. Yeah? And the question is, first of all, where do we see these social tipping points that can help us shift into emergency mode and get the rapid decarbonization that is required? And there is some research looking into, well, how can we trigger social tipping points in terms of, renewables being cheaper, in terms of norms shifting, and so on and so forth. And there's some hope in this domain. Okay, so it's really this race, if you want, between climate tipping points on the one hand and social tipping points on the other hand. But what we think I need to do here individually, and I really mean you individually and me individually, is to take this information really to heart, and realize that this is the greatest crisis that we've ever faced, and we have to come together and try to tackle it. And there are a couple of ways we can do it. There's a nice paper by Christian Nielsen and others, 2021, looking at, as a privileged individual as we are, what can we do, what kind of the levers that we have, and they looked at it from a consumer perspective, from an investor perspective, as a citizen, as a role model, as an organizational participant. And of course, one thing is to reduce your carbon footprint, not because it's particularly effective if you do it alone, if you're an individual and you don't eat meat anymore and so on, but because it can help shift social norms. And the big things are lowering air travel, stop driving petrol cars, that kind of stuff. But the important thing is to talk about it, and say look, this is the greatest crisis. I've made this change. Are you going to join me, and so on. But that's not the most important thing. There's other things where we can look at the organizational level on the mesoscale. Okay, not on the individual scale, not on the national scale, because that's difficult, but on the organizational scale. How can we change the institutions we're in? Okay, for example, changing the cafeteria to focus more on plant-based food, okay, or trying to shift the university to cut their ties with the fossil industry, to revoke their social license, that kind of stuff. Like where we are in our organizations, where can we make a difference? And then so on and so on and so forth. But I think, so there's a big role for advocacy and blah, 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 and talking and so on and so forth. But I think we have to also be real that it's very late, okay? It's really very late. And you see that with these mitigation pathways. And I think more and more people and more social movements, of course, are shifting their tactics towards what's called civil resistance, okay? And civil resistance is a method to change the status quo using a diverse set of non-violent, non-institutional actions, okay? Strikes, boycotts, occupations, protests. Yeah? And civil resistance is as old as human societies. Yeah? There have always been people struggling against oppressors, yeah? Using non-violent means because they didn't have the arms. But it entered the lexicon quite recently in the 19th century when Thoreau was jailed. He was not paying his taxes because he protested the American-Mexican War and slavery. So he didn't pay his taxes, got jailed, what are you going to do? And then he wrote this essay on the duty of civil disobedience, okay? And he said, look, if there's a law that is unjust, to not be complicit with this law, you have to break this law. And civil disobedience has many definitions. There's one famous one. It's a public, conscientious, and non-violent breach of the law with the aim to bring about a change in laws and policies. Okay, so it's important. It's public, it's intentful, and it's a breach of a law or something. Now, historically, this is how change has happened, right? You have historical examples with Gandhi, with Martin Luther King, with the suffragettes, famously in the 70s with a campaign in the Netherlands, Stop the Kindermoord. I don't know whether you know of this. This is why we have nice bike lanes now, because the car was ascending, but many kids died, and then parents came together and was protesting. They were staging die-ins here at Museumsplein, blocking roads, fake painting, bike pathways, and going there anyway, and so on. And over the years, they just grew so strong in terms of the policy pressure that the government said, okay, actually we're backing off with our destruction of neighborhoods for the cars, and we're building out the bike lanes. Okay, this is one key reason why the Netherlands is a bike paradise. Similarly, the 8-hour working week, the weekend. These are successes of social struggle. Okay, because again, the status quo doesn't give you stuff for free. Okay, you have to demand it. And famously, you have, of course, civil disobedience campaigns, civil resistance campaigns all over the world, blocking pipelines, protecting the ecosystems. There's a nice atlas, the Environmental Justice Atlas, who's kind of codifying, quantifying those. You have Fridays for Futures, as many of you know, probably 2018, right? Burst onto the scene, civil disobedience, not going to school on a Friday, and then growing to a movement all around the world. You have Extinction Rebellion, right? Famously putting kind of this notion of climate emergency onto the map, right? This is part of the reason why we're talking about a climate emergency now. But what you don't see here in general is kind of scientists engaging in these actions. And historically, scientists have kind of warned humanity, right? It's like they wrote like these essays in 1992, very famous one, very prescient. Recommend to read it. The IPCC reports, right? All this trying to inform policymakers. Yeah. Recently, they've also kind of started to write letters in support of Fridays for Futures, in support of Extinction Rebellion. And there have been isolated incidences of scientists engaging in civil disobedience. Yeah. So you have James Hansen. We've met him in 1988 when he testified before Congress, here getting arrested for blocking the Keystone XL pipeline in 2011. And he said, Einstein said, to think and not act is a crime. If we understand the situation, we must try to make it clear. Okay? I decided 6 or 7 years ago that I didn't want my grandchildren to look back in the future and say, like, Opa understood what was happening, but he didn't make it clear. And this is this, I think, great power of civil disobedience actions that can pierce through the noise and really alert society to a particular issue that, for example, IPCC press release doesn't really do. I mean, if you've ever been to a press conference of the IPCC, it's so boring. It's so boring, it's actually scary how boring it is. But if climate scientists and other scientists engage onto the streets, they can pierce through the noise very powerfully. And this is kind of what we're arguing for and pushing for with Scientist Rebellion, trying to mobilize the academic community to engage in civil disobedience. Because we think this is really how change can happen on short timescales. And in last April, when the Working Group 3 report of the IPCC came out, we mobilized over 1,000 scientists engaging in civil disobedience in 26 countries, mass arrests, occupations, strikes, teach-ins, and so on. And that spawned these scientist rebellion groups locally. And it's a kind of, if you want a sister organization to Extinction Rebellion, it's kind of the scientific arm, even though we're quite independent. And there are many videos from these actions to give you a flavor. Given that we only have 9 minutes left, I'm not going to show you this one. It's very nice. Peter Kalmus, maybe you've seen it, NASA climate scientist chaining himself to Chase Bank, and tearing up and saying, look, guys, this is an emergency, we need to act. Going viral on TikTok. One of the things, TikTok seems to be the place to be. What we did in the Netherlands, and maybe you've seen some of the stuff, is this action at Schiphol in November. So this was organized by Greenpeace and Extinction Rebellion, and we mobilized people giving direct action trainings to, in the hundreds. We were like 500 people, and we walked onto the private jet terminal, okay? And they couldn't stop us. So we walked onto the private jet terminal, and we just sat in front of the private jets. You see us here, and maybe you've seen some of the videos of Dutch people biking on the private jet tarmac and the police running around and trying to get them. And then, after a couple of hours, they tried to arrest us. So they took us into buses, and then they let us wait in buses, and we were like 300 people. And then they realized they don't have the capacity to charge us, process us, and so they let us all free. Okay. And what this did is put, again, this notion of excessive carbon inequality, private jets, onto the map, and it was covered in the New York Times, in the Guardian, the Washington Post, everywhere. And it put it on the agenda also for the Dutch Parliament, and so on. It's being discussed now. Similarly, Extinction Rebellion, there's a lot of actions on fossil subsidies. The Dutch government spends like 18 billion per year on fossil subsidies, only a third of it on the renewable energy transition. And they are blocking the A12 at the Tweede Kamer in The Hague. And recently, we joined them with 30 academics blocking the road. There were 1,000 people in total, 770 or so arrested, which all fine. You do that, nothing really happens to you. But you draw attention to the injustice and the craziness of subsidizing fossil fuels when we have to get off them as quickly as possible. And so I think these actions is kind of what is available to us as tools, now in this critical decade. Yeah? There's not enough time, I don't know, for you or for me to become a professor and then try to make some policy change, blah, 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 blah. But this is a tool that is available to us now. And it is quite powerful if more and more people are doing it, and more people are doing it. And it's interesting, I think, one of the experiences I had when we went to Lützerath, maybe some of you were there, so where a village is destroyed, is scheduled to be destroyed to expand a coal mine. Okay, and this is in Germany with the Greens in power. Okay, and we were there with camping, and we were there with like 35,000 people, and the village was being evicted by the police and by RWE, the fossil company, and we tried to take the village back. Yeah, and we were like 35,000 people, and there was a village, and we were walking on a legal demo, and then at some point we turned to the left, and we ran with thousands of people towards the village. Yeah, I never thought I would do this, but then we ran to the village, and there was this question of cat and mouse, of chess. Can you somehow get to the village beyond the police line? And then there's this complex system problem of getting people to come to you so that you can open the police line and people running through. At the end of the day, we couldn't take the village. There was an enormous amount of police. There was pepper sprays, there was dogs, there was horses, there was water cannons, and so on, a lot of police violence. And I think one of the things that crystallized for me is you have the Greens in power. It should be a progressive party, still destroying this village for coal. This is not needed. Yeah, you realize that, okay, once you're in power, it just warps you. The mega machine kind of takes you in, and it kind of fossilizes your interests, and you're becoming part of the status quo, and like, we have to go slow, we have to take these people with you, and so on, so against radical action. And you also realize, when you stand there, okay, in front of thousands of police, you realize that nobody is coming to save you, okay? Nobody is coming to save us. Yeah? It's not that at some point politicians will realize, of course we should do climate protection, obviously. It's obviously better for everybody. Yeah? Or there's going to be this magic technology that solves the problem. Yeah? It's really, I think, upon us to engage as individuals in groups to push for climate action on the policy level, because nobody is going to do it otherwise. Yeah? And I want to leave you with those words. Of action, actually, and of trying to get involved. And thank you for your attention. I think it was quite long.